introduction, Heidi. I'm Shilad Sen. I'm a professor of computer science at Macalester. I saw we have some students, and we have at least one alum, but several more alums. Is that right? Yes, I love it. So I'm going to start us off. I'm going to hand off to Susan right after. But first, so I'm curious, was anyone downtown yesterday when the electricity went out? Yes. So I was out to dinner. My daughter turned 12 yesterday, and so we went out to a birthday dinner with her. And we went out to fondue, because that's a fun thing to do with teenagers and pre-teenagers. And we were having a great time. But while we were at dinner, the power cut out. And at a fondue place, if the power cuts out, you can't, we just had to stop because the pot got cold. And so we were trying to just make conversation with our teenager and my wife and I, with our teenager and our pre-teenager. And I said, hey, I'm giving this talk tomorrow on the future of computer science. What are the things you think I should talk about? And my son, who's 13 going on 14, he said, you should talk about how everyone should be allowed to use ChatGPT. And I was like, okay, so we are going to talk about that towards the end. We have some big questions for you, and that's related to one of them. And my daughter said, before I thought I understood what programming was, and then I went to this website, code.org. How many of you have been to code.org? And I got to write this program to make these characters do these things, and I was so excited by that. And that idea will also be part of this talk, that there's these other pathways that we think are really, really, really crucial to growing the field, and especially growing important perspectives that are underrepresented in this field. So I want to kind of give away a little bit of our punchline here, because I think it has been emphasized so well by our speakers, Ian and Jam. They talked about the importance of relationships, and we're going to be talking about the future of computer science. But I think one theme you'll hear from both of us, that there's not an answer to the future of computer science. It's not a static answer we can just tell you. We can tell you what we're doing right now. But the answer is really a process. And I know that Susan and I both feel incredibly, incredibly privileged and fortunate to be at a small liberal arts college that is in a city. And many of us who are faculty members chose to be in a city because we want to do our work in the context of everything that is happening around it. And we think the way that we keep our program, which we are both very proud of, moving forward is through relationships, by understanding what our incoming students are excited about and want, by understanding what our grads who are looking for jobs, many of whom, including many of these grads, need in order to be competitive, and by what our kind of alumni who have been out doing things longer tell us is most valuable from their education. So it really is more of a process than it is an answer. So we're going to start emphasizing process and community by asking you all to reflect on your own experiences, whatever that means for CS. And I hope that you take you engage with this. Susan's going to run that. Then Susan's going to tell you a little about the CS curriculum. And we're going to put you in the seat of two of our favorite classes, our intro class and our very first semester class, and our software dev class, which you would probably take as a sophomore. And then we have some big questions for the future. But before we get started, we're both going to tell you a little bit about ourselves. And so I'll start. And this is a standard slide I have, and I'm just going to touch on a couple points. The first is, so I started my career at a startup. It was a startup that built movie recommender systems that were interacted with touchscreens in the late 90s. We sent them into video stores. Blockbuster was, we had an exclusive with Blockbuster and Hollywood Video and Comcast. It was a pre-2.2 Linux kernel. It was Red Hat, something like 4.2 or something. It was very old Red Hat. We were programming, I wrote touchscreen device drivers, and these systems had to live pretty independently, only periodically speaking to us on a modem line. And I came to love developing those kinds of systems, and my career has really been about working on AI systems for new emerging areas. I'm kind of a generalist in that area. I do all kinds of things. I took the traditional CS track, so I went to school at the University of Minnesota. I never thought I would be a professor, but I thought, why not try a job at Macalester? And I loved it. It's what I'll be doing for the rest of my life. But after I was tenured, I kind of missed my industry work that I had been doing, and so I kind of spun up a bunch of industry work. So I've worked for Target, I've worked for Microsoft for the chief scientist on Copilot-related things, and I now work for Indeed on their Gen AI experiences. And my work is really developing systems for new and emerging AI problems that we think are really strategic and impactful, and that always involves deploying systems. So I have a real appreciation for all of the work that you do, both from my experience prior to academia and from my experience now. So I'm going to hand off to Susan. She's going to take you through the middle half of this talk.
All right, so Shilad showed me his slide, and I went, oh my, I can't beat that. So I sort of did my bio slide here as an answer to Shilad. I'm not Shilad. I'm an academic. I had a one-summer job as my sole industry experience. Okay, I went straight from undergrad to graduate school. Graduate school, I came to Macalester, and I've been there ever since, and I hope never to leave. This is my life. So a couple of other things that I put up here. I am very much focused on teaching. That is my love, and I have been department chair. I will be department chair for like 4 or 5 more months. I've been department chair for 5 years. I'm looking forward to not being department chair so I can teach more, among other things. But I also have research interests, and I keep an active research program, and that's where I kind of connect to a lot of really interesting things that are going on. So I started out in a very esoteric part of AI when I was an undergrad or a graduate student, and then I couldn't tell students about it and make sense of it to them when I got to Macalester. So I shifted into robotics. That was a whole new area, and I've kind of had this long, meandering path of working with robots over the years and trying to work in machine learning wherever I could. So I do robotics, machine learning, computer vision, and these days deep learning. And because of the growth of AI, I've been really interested in the social implications of artificial intelligence and how we work that into the training that our students have so that they come out as ethical practitioners in the long run. All right, so that's enough about me. Now we want to hear from you. So I'm going to do a sort of typical classroom activity with you all, because I'm a teacher and that's what I do. We want to know what do you remember about what your CS education was like? So there are several different aspects of that, perhaps. What was your required curriculum? What courses do you remember that were key to that? What were the topics that were the focus of your education? How did the classes run? Well, how did teachers teach? And what was missing from your education? So I'm going to ask you to think about that and then turn around to the folks nearby you, if there are any. Introduce yourselves if you don't know each other, because why not? We're at a conference. That's what you do. And talk to each other for a couple of minutes. And after a couple of minutes, I'll ask for volunteers to sort of share out anything that you want to share about what your CS education was like. All right. Let's give you all a chance to share with the group. We have a couple folks with microphones here, so if you'd raise your hand and I'll point to somebody and they'll bring you the mic. Wait till you get the mic to talk so that everybody can hear. All right, who wants to share something out?
Hi, everyone. Oh, that's very, very, very hot. Okay. When I had my bachelor's back in 2007, I ended up having a lot of required courses. There was a lot of calculus in my curriculum. There was a lot of theoretical Not a lot of practical. When I left the University of Minnesota, I ended up having like 2 job opportunities. The one was database administration, the other was digital forensics, and I learned a lot more in digital forensics than I did in database administration, which was my focus at the time. But one of the things that I've noticed a lot in some of like the bigger universities is they don't focus on industry application, and a lot of the continuous deployment, continuous integration, pipelines, taking that infrastructure as code mentality and applying that same software development methodology to infrastructure systems and systems as a whole.
Right. Our group, I started with talking, I graduated 10 years ago, 2013, and did an internship. And the one thing I thought was really lacking in the curriculum was source code management. And that was hit home so hard in the internship. It was like everything was source code management. They were in, I think, Perforce or something. But at the university, we easily could have checked in our assignments with Git instead of zipping it up and emailing it to our professor.
Who else?
Hi, I'm Willie, and I have a studio art degree from the 90s. But the one thing that I think about along the lines of this Git business is like that's the mechanism we use to work with each other, and it wraps into this whole theme of kind of this community aspect. And that's the one thing that I wish that we had a much better grounding of. Been working in higher ed for 15 years now, so I see a lot of it.
So, hi. I'm an economics major, but I did take computer science classes in school. And kind of afterwards, looking back, also talking with someone who is a bona fide computer scientist who like lives and thinks in the theory. I guess one of the observations I had is there seems to be kind of a demand for essentially software engineering, but that's distinctly different than, in my mind, than computer science. So in computer science, you need to understand the theory, you need to understand kind of the concepts. That's all very important, but like how do we distinguish that from the engineering that's needed to actually do the work of creating software every day?
Susan, Dan Nordquist, McAllister 98. I finished with a math degree. Computer science for me was rough because my second year I had an 8 a.m. Fortran class, and it was just not a fit for a couple of different reasons. But I feel like the benefit of a McAllister education was really being able to take some of those concepts and talk to people that were in classics and people that were doing women's studies and people that were doing paper making and things like that. So that's really been my superpower for the past 25 years.
I graduated in 2017. I think the biggest thing was there was a huge focus on the insides of like algorithms and logic and stuff like that, and then a focus on software development. But I didn't take any classes about server management or CI/CD or open source and how to use it. And I think those would have been really helpful. And maybe those were offered as electives, but it was hard to know when you're 20 years old what your interests are going to be, what's going to be valuable. So maybe looking back, I should have taken some of those, and I didn't know.
I was a University of Minnesota student 2016 to 2019-ish, and I think the big thing for me that really felt missing, not only a lot of people have talked about like applications or like how we work together, but I think I got about 15 minutes in one lecture about how to be responsible with all of the tools that they were giving us and how to be ethical with what we were learning. And I know that there were other classes that were optional that you could take on that, but no one was really incentivized to like incorporate ethics into the computer science that they were practicing and teaching.
All right, maybe one more.
Yeah, kind of riffing on the same theme. I graduated in 2004. I actually did have an entire ethics course, but the interesting thing about the ethics course that I got in my computer science education was there was no industry application. My ethics course was about like the main topic that they covered was this old case of somebody being exposed to radiation from a medical device, and how a software bug had caused a fatality. But the ethical issues that I've run into in industry, my computer science education really did not prepare me for addressing those. And there was a really serious situation that I ended up being asked to choose between putting someone's life at risk versus compromising their privacy in a call center context in an industry application. And that to me was like a situation I felt very unprepared for by my computer science education. So I think that would be something that I would love to see people focusing on a lot more.
All right, I'm going to stop there just so that we can talk about some other things too. But thank you all. That brought up, I think, a lot of the points that we were thinking of. And I'll say that we're going to talk about our curriculum. We're a small school, which has advantages in that it's easier to be a little more nimble with our curriculum. And so we're trying to be a little more forward-thinking and a little more maybe applied. I don't know. There are a lot of words we could use. So these were some things that I came up with in thinking about, like, what do we think of as the traditional CS education? Some of them were mentioned. Emphasis on theory. I think of a lot of like courses and the topics that were focused on computer science for itself, like writing compilers, which is totally cool, don't get me wrong. I love taking a course on compiler writing, but it's not something everyone does. It's actually not a very small niche. And other sorts of things like a database course that's all about the algorithms that you need if you're going to build a database system from scratch rather than how you actually use databases, and those sorts of things. So yeah, there are lots of other things about like classroom style and those kind of things that we think of a lot because that's our focus. All right, so what I want to do next is to give you just a brief overview of what Macallister's overall CS curriculum looks like. And then we'll talk about a couple of individual courses to give you a flavor for the kinds of things we're trying to do. So just to give you context, for those of you who are not alumni, Macallister is a small liberal arts college. Undergraduates only, about 2,100, 2,200 students these days. It's a little bigger than it used to be for some of the older alum. It's got a very much of a liberal arts focus. The way that impacts us in terms of our curriculum is that we have a limit on how many courses we can require a student to take. We require 12 courses out of a student's, what would it be, 64 courses?
Yeah.
that they take as an undergrad. We have small-ish class sizes. We would like them to be smaller than they are now because we've had kind of booming enrollments. But our intro courses number about 30 students. It's a very different context than a large university. But it also makes it easy for us to have a kind of interdisciplinary and outward-looking perspective in terms of the courses that we offer and how we think about computer science. All right, so this is a picture of our computer science major, just to give you like a big view of it. Down at the bottom, you can see we have math courses. We require discrete math, and then any other 2 mathematics or statistics courses that the student would like to take. So some of that's calculus. More often, we recommend linear algebra, which at Macallister they can take after taking discrete. And then students also opt fairly frequently to take 1 or 2 statistics courses as well. We have a 3-course introductory sequence, which is really oriented around developing skills and confidence as a programmer. First in sort of Python-ish terms, and then using object-oriented development and understanding data structures in the context of coding. We have a 3 set of core courses that cover topics that we think everybody needs to see. We'll talk about the software development course later. We have an algorithms course, which is fairly typical, and a computer systems course, which we use as a tool to teach the students C, so that they see it for some of the later things. And then we have a lot of electives. You can read the list. It's rather an unusual list, I think. It doesn't have some things that even we might like to have, but it also has some really interesting and different electives for students to take. One of the things we've talked about as a curriculum is working in ethics across the curriculum. We're still in the process of actually being able to do that, but we do have a new, it's going to change its name, but it was basically computer science and society elective that was about like social implications of computer science. All right, I'm going to then wrap up by telling you about my favorite course, which is our intro course. I started it, but it's been a collaborative process. There's been input and new materials and updates that have happened over 10 years that we've been teaching this course. Core Concepts in Computer Science, the name actually probably predates the course in its current form. But we really set out to reboot what we thought of as happening in the intro course. And I'll give you a little context about it. It is first course for absolute beginners. You do not need to have done any programming before. We try to reserve seats for students who are not just incoming first-year students, because we want to have students who maybe are in their junior year try a little programming, and maybe they get inspired. That's happened before, that we've had students who've either smushed in a major in a short term, or they've minored, or they've gone on to do things in the tech world with a little bit of background. Our course is based in Python, and it's function-based programming. So we do spend a lot of time talking about objects, but they don't actually build classes until the very end of the course, and then they barely get it. It's like they see it, and they're like, OK, this is a new thing. But they do spend a lot of time sort of learning the basics of programming. All right, so what was the ethos that we had when we created this course and that we keep as we go forward with it? There are 4 things that we really want this course to be for students. First and foremost, we want it to be welcoming. Far too often, and it was true of our previous intro courses, students come into an Intro CS course knowing very little, and they get turned off and they quit, right? And at some big schools, they just accept as a matter of course having 25% of the students who take their Intro CS courses either fail or drop out. That's appalling, honestly. So we designed this course to be something that you could come into with no background and actually become successful. So it has a fairly gentle slope of learning, and we're selective in the topics that we choose to cover to make sure that it's not something you have to have a strong background who've done computing before in order to be successful. And we were trying to target a broad range of students from different backgrounds and different interests. The second thing we want is we want the course to be exciting. So we do not have them build a simulation of an ATM. I can't tell you how many Intro CS books, that's one of the first projects, is let's build a doesn't that just fire you up with the whole joy of computer science? No, so we selected topics that are visual, that are attention-grabbing, that are fun for students to work with, so that they see all the really cool, fun, creative aspects of the field right from the start, and they can see themselves doing something fun and interesting with what they're learning. The third one there is useful. So in addition to being fun and exciting, we also want to make sure that a student who comes into this class and doesn't ever take another class learns something they might actually be able to use. So that means we talk about a few topics in the course that are just handy almost no matter what field you might go into. The fourth aspect is active. So a lot of traditional CS or in places where you just have really large class sizes, you almost have to have this. You'll have like a lecture and then a lab. And when you're in the lecture, you sit there and the professor talks and does examples and you take notes. And we just don't feel like that's a great way to learn programming, particularly. It's a great way to learn certain things, but programming is not going to work very well that way. So we don't have a separate lab for this class, but all of the hours of this class are in a lab. And we try as instructors to limit our conversation, our presentation, to say on average 15 minutes of class time. And the rest of that time, they're doing an activity while we and our TAs are there in the room circulating and making sure that they don't get stuck and spend a half an hour not making any progress whatsoever. So if they have questions, they can get them answered. I tell my students, if you're stuck for 1 minute in class, that's it. If it's been a minute, your hand should be in the air, because there's no point in me standing there and them being stuck. At the same time, we try really hard not to just like give them the answer, but to use that as a chance to figure out what they need to learn in order to progress. All right, so this is really my last, I think, last slide. So I wanted to sort of summarize the ideas we have in the class and then the things that we do, the topics, the applications. So we talk about control structures. These are your basic things, loops and functions and conditionals and how variable assignment works and those kinds of things. We talk about data representation, both simple and complex kinds of data. We talk about algorithms a bit. And we talk about design, because we want the students to take ownership of this field. So we talk about how you can do designing a program that's larger than one function, so that they actually get those experiences. So control structures, we start with turtle graphics. I don't know if any of you have seen those. It's really fun. It's really visual. It's pretty. One of my favorite first homework assignments is draw a tree. I don't care what it looks like. Figure it out. Draw some kind of tree with at least like X number of elements to it. And that's a place where we bring in some design. We also teach them graphical user interfaces, a very simple kind. But again, that is our chance to introduce classes to them. And that's another control structure that we work into the mix. Data representation, we start with numbers, but we also start with turtles, which are objects and have state and methods. And we talk about data representation in the case of text, or even things like reading in a CSV file and how we represent that and work with it. And we talk about images and how you can represent images inside the computer. We do a little bit with algorithms. We do fractals. So that comes up in turtle graphics. They can draw fractals. We do some text and data analysis, so things like frequency counting and aggregating data in various ways. And we do some things like green screen processing and other sorts of things on images where we give them some algorithms to work with. And as I said, at the very end of the class, after they've learned everything else, they have a project, and that's a design your own. So we say, here you go, you have a team, pick a topic, write a design for how the program's going to work, and then implement it. And that's like the most fun section of the class. All right, so to sum up, this is a course that serves majors and non-majors. Our demographics in this course match the college demographics in diversity, which is an amazing thing, and it's successful. And we draw a lot of students into the major out of this course. I can't tell you how many students have said to me, I took your course for fun, and that's how I became a major. And it is an active and happy classroom. It is one of the most fun courses ever to teach. So I'm going to stop there, and I'll let Shilad take over with one of our other super fun courses.
All right, so I'm going to be talking to you about our software dev course. This is a course that you would take probably in your second year, maybe your third year at Macalester. And I just want to acknowledge that this is the brainchild of Paul Cantrell, who many of you probably know. I know he's a member of this community. If you ask students to pick their two favorite professors in computer science, Susan and Paul would be, I don't know who would win. It'd be one of the two of them. And the way this course works, first of all, 16 students, 4 groups of 4. And the idea is you try to get them in groups, and you try to get them to work on projects as quickly as possible, and then just stuff comes up. And the stuff comes up is where the learning happens. We kind of structure the class around this. And I've taken a little excerpt from Paul's syllabus here. I've taught this course many times. I love it. But you can see it's really like a critique-based class, and it's one that involves all the students in that critique. So when I started teaching this, it was kind of awesome and terrifying. Now it's just so fun, really fun class to teach. The way it looks is we have roughly a 12-week semester. In week 0, in the very first week, we're putting students in groups, and we have a very deliberate way of how we do that. We don't let students just willy-nilly pick their own groups. We survey them. We have a very careful way we do it. Within the first week and a half, they've already chosen a project. That project often changes dramatically over the course of 12 weeks. We have them pick a framework in their second week. So they're going right away. They're going. And throughout the semester, we have a whole bunch of different things sprinkled in. There are skill-focused classes. So like one of you talked about Git and wanting more experience in Git. We have an activity we ran where the idea is just to get students in trouble. So you have them write a story using Git. You have them kind of create chapters for that story. And at some point, you're like, go. Everyone go. Go until you get a merge conflict. And once you get a merge conflict, let's stop and we'll all look at it. So they'll class stop, so we all look at it. We talk about what you see. What does it mean? So that's the way we kind of do this. That is a dedicated unit. But then it's great because you come back later in the semester and you talk about merge conflicts and you remind them of how it all works. Then the way the course works after that, so format-wise, typically you have a work day about once a week. You have a sharing day, so teams know they're on the deck to share out the work they've done. And during the sharing days, it's also critique, and I'll talk more about that. You have a few skill days. You have guest speakers. Someone talked about ethics, and Susan mentioned that we try to sprinkle ethics throughout our courses. We actively sprinkle them throughout. Every course has a deliberate ethics component. The best way to do ethics that I found is to have guest speakers come in and share an experience like what you talked about, because it's hard for students to imagine those types of things unless they have someone in the class. And so we often use guest speakers for that. Our philosophy for this course is to get them working as fast as possible and then just have an idea. So we have a set of topics we want to cover, but instead of having lectures for those topics, during the sharing sessions, they come up. They invariably come up. And that's when we do the learning in the course. So a really mundane example is students come in and they didn't accomplish what they wanted to accomplish. So why is that? So you actually engage in, well, what was your plan? Is that plan written down? How was it written down? Is it clear when you were done, are the tasks assigned to people? All these kinds of very specific things you talk about, and you talk about them not to give that team a hard time. You talk about them as lessons that come up, right? So you have this way of really focusing on minute things. Debugging is another great one. Okay, we're encountering this bug. Okay, let's look at that bug. And let's not just fix the bug, let's have the whole class engaged in that. And let's have some time to reflect on what that process was so that next time we're going to do it, we're going to know how to do it again. So we have all these kind of meta lessons that come up in the moment, and it's just super fun. So here you can see a list of some of the kinds of things that we talk about. Communication is a huge one. And so I think that our grads find that part of software dev, not the just building part, but the collaboration part is one of the most valuable things they get out of the course. At the end, there's a demo. The demo is basically like a party. Students invite their friends, community members come, parents come. They all show up, they demo. It's wonderful. It's really, really, really fun. Okay, so we'd like to close with some big questions, and we'll kind of we'll briefly talk about our thoughts on them, and then we might have time for a few questions. If not, you can grab us during break. So the first is about AI. This is both of our research areas, so we both have lots of thoughts on this. It's an ongoing topic. And the way we approach this is, again, to focus on student needs. And our operating theory right now is that in the intro series, you really shouldn't be using AI except for very simple autocomplete. And even then, there's problems with it. So we try to discourage AI in our intro classes. But then starting in our intermediate classes, often the second year, it's a first class, kind of using AI-based tooling is a first class concept. So we talk about how you will use it, how you credit it, how you ensure that you're actually using it effectively and carefully, and not, Susan used this word, not in the danger zone of just accepting kind of what it gives at you. So we make it a first class entity, kind of starting around that software dev area. A thing we're thinking about is how do we convince students that in the entry series they shouldn't use it, that they actually, so we have some ideas on that. We're still working through that, but we would love to hear your thoughts. Another thing that we think a lot about is how to choose what we focus on. So as Susan said, we have a set number of courses in our major. We have a set number of people at the college. And we both would love to introduce a course like operating systems that is taught very irregularly. And we would also love to have a course that's dedicated on Gen AI. But we can't do either of those things. So we're often caught with like really, really, really thinking hard about the minimal set of things that we can offer. And our philosophy on this is to focus on kind of foundational things. Like, we don't need to teach every programming language. We need to teach students to be able to learn a new programming language. You know, in order to do that, it's important to understand pointers. It's important to understand dynamic language, statically typed languages. And then once they do that, they can kind of learn stuff on their own. So we really focus on those foundational principles. And we try to do things that are in the wheelhouse of our current faculty, because we feel that is what they're most effective at doing. A big open question is one that you all brought up. Something that feels like it's atrophying both in our curriculum and in our income students, which Susan will talk about, is the idea that there's fluency on the command line, at the very least. That's even much simpler than CI/CD and things like that, right? Just fluency on the command line. So that's a challenge.
Yeah, so our third big question is really a constant change. There is never static skills that students come. But over time, we've seen this change in what students' skills and familiarity with technology look like. Our current students come in and they're like, oh yeah, we're pros with technology. They don't know there's a file system. Because the computers these days, as a user, those things are hidden from you deliberately by the operating system to make it user-friendly. So there's a lot of stuff that we need to now teach our students that 10 years ago we didn't have to teach them, because if they used a computer, they knew these basic sorts of concepts. So some of that is command line work. Some of that's just understanding the underlying guts of the machine that are more and more hidden. And also understanding different architectures, like all the different kinds of technology they might be working with. So we don't have answers to these. We're just kind of thinking about them. And so I think what I'd like to do is to wrap things up. We'll take some questions here, and then I think maybe Shilad and I can stick around, and we'd love to have some more conversations afterwards as well.
All right, we're going to take questions over here.
Hi, name's Benjamin. I think one thing that stood out to me when you were talking about like group-based project work is most of the time one person probably do 80% of the work, and then 3 people would just show up the last 2 weeks and try to be part of the group. So I guess, how do you guys account for that? And I'm not even saying that in a sort of negative way. Some people are product managers and think that way. You know, some people are more like systems engineers. So is your curriculum like kind of like addressing that? And I guess, what was the other thing I was thinking about? Yeah, how do we educate like engineers on the different stages of their career growth? Like you're on this level, and then can you deal with ambiguity and like, you know, so that they understand that like it's not just going to be one level that they're on for a long time?
I'll start with the start of the question, and then you can pick it up if you want. Yeah, I think we do a lot of group work, and we do try to talk to students explicitly about taking on roles in the team. It doesn't always, there are always dysfunctional teams. It's going to happen. But we do try to explicitly teach good team processes and communication and making sure that, maybe it's partially our students. Like the students who don't get to engage often are upset that they feel closed out of when you have one person who kind of takes it on and does the whole project. So that's more common for our students than a student who just doesn't do anything and just is a dead weight on the team. So part of it is our scale. I think we can keep closer tabs on students during teamwork than you could if you had larger teams. So I try to keep an eye on them and poke the teams to do a little better when I see them not working well. Yeah. I don't know.
And just a couple additions. So in software dev and some of the other later courses, many of us explicitly survey teams. So we'll talk about individuals, we'll ask how much they've contributed, and we'll tell them their peers will also assess that. It's remarkable how honest they are. They often someone who maybe was on the edge of carrying their weight will say they didn't do enough. And that's and then your second part of your question, guest speakers is the answer. I feel like that's the best way to do that, to have people come in at all different stages of their career, and then the students ask questions. I have a kind of protocol I use to make sure it's student-led.
My question is there any specific pieces of feedback you've gotten about your curriculum that were very helpful for you in changing it and moving it in a specific direction?
The last review, the biggest piece of feedback, it was about preceptors. I can share that, right? So we have students as TAs, they're undergrads, disproportionately students of color and women, I'd say, international students. And one thing we heard was they didn't always feel that role was a safe role for them. So there was, especially with women TAs, there were situations happening that made them feel unsafe or at least uncomfortable.
Disrespected.
So we've had a whole series of things that we've done. It's a process, but that's probably the biggest recent thing. That maybe was 2 years ago. We had a review that it wasn't like an acute thing. It was more like anyways.
Yeah. This question?
Yeah. So my question's kind of along the software development course that you guys teach. How do you guys teach delivery and user empathy?
We'd love to teach delivery. Just getting them to the point of delivery is so hard that Paul, again, this is Paul's brainchild. Paul has taught a follow-up course, and I think Leanna's thought about teaching that as well, where you focus on that next stage. Well, we have something that we would actually put out to the world, and then what? So I feel like a follow-up course is probably the answer.
Yeah, I saw that you had it listed for robotics, and I'm assuming that's going to be a major, because eventually you'll get some point to work on. I'm just curious, how much do you guys emphasize on learning robotics, developing with it?
Robotics is my research area. I teach an elective. That's all we've got. And I am not a hardware person. So I have some support of a guy who's really good at the hardware stuff who helps out, who's a staff person. But no, we don't have a hardcore big scale robotics program. We have had students who've gone on and done graduate work in robotics or gone into the industry and worked in that field. But yeah, it's just beyond our scope to do much beyond that. I usually work with really low cost robots, which kind of drives the kinds of techniques and algorithms that I work with.
You've taught a first-year course, too, in robotics.
Yes, I have, yeah.
Hi, McAllister. Classics. First CS course with you in Lisp.
Oh, yeah.
Step up above Fortran, maybe.
I love that course, but it needed to go.
One thing that I'm not sure if this is a job for industry or a job for academia, but probably teachers know better how to at least get the ball rolling. But when I think about all the low-code, flowchart-based programming tooling, programming languages really coming out into the world. I mean, how do we teach software engineering with Scratch? How do we teach test-driven development? How do we teach, don't repeat yourself, programming, that kind of stuff? Because what I'm seeing is that people are getting a lot done very quickly, and I haven't seen a lot out there for making sure that all those people don't have to bash their heads against the wall in industry. So, I don't know, physics for poets, but software engineering for Zapier.
I think that's great. I know that, I don't know much about it, but I go to the Computer Science Education Conference every year, and I know there are people working on blocks-based programming languages that scale up, and that at some point maybe transition into the code itself. I've wondered for like 10 or 15 years why we still write code in text, right? Why not have a completely different modality? Paul Cantrell actually started me thinking that way when he was an undergrad eons ago. So no, I think that's be super exciting. So,
last question.
Sort of to piggyback on text, what text editor are the kids using these days? we were Emacs and Scheme when I was, as my nephews like to call the 1900s when I was in college. But
I think most of our students use VS Code. I think for the Python course, we've stuck with PyCharm because it's a better support for Python, easier to work with than VS Code. But yeah, ask our students, they prefer VS Code.
All right. Thank you so much. Big hand of applause.